In this video, I'm going to show you how to use page 10 in the Earth Science reference tables. So let's go to page 10. And on page 10, you're going to see inferred properties of Earth's interior. This is kind of a complicated diagram, but we're going to break it down little by little and make it make sense for you. So first of all, I want to point out this word right here, inferred. Inferred just means that you're judging something due to evidence, right? So what that's really saying is everything that we know about this diagram and about the data that is on this diagram isn't because we've gone to the center of the Earth. We have never been deeper into the Earth than the thickness of the crust. And so we know the information that's in here based on other data, mainly from seismic data, earthquake data. So that's what that word means. And all of this information here is all the properties of the Earth's interior inside of the Earth. So I want to start off with this picture just to kind of break this down. You've seen this before where you have like a slice of the Earth. This is if we took a part of the Earth and cut it, sliced it in half, and now we're just looking at a little piece of it. If you were to extend all of this around, you'd have the whole circle of the Earth. And they even label the Earth's center is right here for you so that you know that. And the lovely part about this is the Earth Science reference tables. A lot of the information that you've been learning this week, you don't have to memorize. It's all right here in the reference tables. So each of these different levels, these different layers of the Earth are all listed here. So for example, we have the core, the inner and the outer core are listed here. And then the mantle, there are 3 different types of mantle that are listed here. And we've learned essentially a couple of them, but we haven't learned all of these. We haven't talked about all of these. But you can see that we've got the stiffer mantle, we've got the plastic mantle, and we've got the rigid mantle. So the rigid mantle is what it sounds like. It's rigid, it's rock-like. And when you pair that with the crust, those 2 pieces make up the lithosphere. So it's all right here. It tells you exactly what the lithosphere is. The asthenosphere is underneath it. It's also called the plastic mantle. And if you remember from the Ed Puzzle video, this is the stuff that is kind of the consistency of silly putty, right? So you can move it. It's a solid, but it moves very, very slowly. And this is the area where you have all of these convection currents. And you can see the little arrows. The arrows tell you that this is where all of the convection currents or the convection cells are located, right there in the asthenosphere. Okay? Something else that you should be aware of is the data that is given here in this table. So over on the left-hand side over here, they tell you the density of all of these different layers. So the density of the crust, continental and oceanic, are listed here. And all of the numbers that are underneath here, these are also densities of all of these different layers. So the density of the stiffer mantle is listed here. The density of the cores, the outer and the inner core are listed here as well. So now that we've taken a look at that, let's take a look. I'm going to erase some of this stuff because there's a lot of information here so that we can kind of look at this in the bigger sense. So I'm going to zoom out here for you so that we can see this whole thing, because I know that this is a little bit complicated. We're going to take a look at the whole thing now, okay? There are basically 3 parts, well, kind of 4 parts to this. You've got the diagram that we just looked at the top, and you've also got some graphs underneath at the bottom. And the graphs themselves show you 2 things. Number 1, you've got the pressure that's listed here. So if you were to go down into the deep depths of the Earth, how much pressure are all of those materials under? And we've also got a table, or a graph, I should say, of temperature. And then at the very bottom, I kind of covered it up here, so let's erase that. At the very bottom, we have the depth. So if you wanted to know how deep you're going for each layer, the depth is down here. And this is in kilometers. So if you were to compare, 1,000 kilometers is the same thing as about 600 miles, just to kind of give you a comparison of what those numbers mean. So we're going to take a look at each or actually one section, just to give you an idea how these graphs work. And I'm going to take a look right here at the boundary between the asthenosphere and the stiffer mantle. Or you could talk about this, you could say this is the bottom of the asthenosphere. Or you could say that this is the top of the stiffer mantle, right? So either one of those, any of those ways to describe this boundary layer that I'm looking at here, this little boundary between these two layers. And if I wanted to know, for example, well, how deep is that? Like how far down does that go? I would just follow that layer, that boundary, and you can even see there's a nice dotted line or a dashed line on the reference tables that kind of guides you all the way down to the bottom. And if I zoom in on that so I can see it a little bit better, you can see that that boundary between those two layers is, if this is 0 and this is 1,000, oops, right about here is probably halfway, which would be 500. And then this would be 600, 700, 800, 900. So that's maybe about, I don't know, 550 kilometers down into the earth, right? So you just kind of have to estimate. But that's how you could figure out how deep each of these different layers are. And you could do that for any of the boundaries or within a layer itself to figure out, like, how deep is that? Okay, that's the depth. And then you can also figure out, well, how much pressure is there on the materials that are down there? We talked about how the inner core is under a tremendous amount of pressure, right? Well, what is it like? What's the pressure like at this boundary between the asthenosphere and the stiffer mantle, or any of these boundaries? So if you follow that line again straight down until it matches up with this dark line, that is the pressure graph. That is the pressure line graph. And so where those two cross, or where they intersect, if you were to follow that straight across, you could read off the number for the pressure. And now I know that that's gotten a little crazy here, so let's get rid of all of that so we can see it a little bit better. And where they intersect, oops, technology, where they intersect right here and follow that across, then you would just read off the pressure. So it's going to be in between 0 and 1 million atmospheres. What? An atmosphere is just, well, the atmosphere. It's the sky. It's the air, right? So at sea level, on the surface of the Earth, on the crust, we have exactly 1 atmosphere, not 1 million atmospheres. We have 1 atmosphere, right? It's the whole sky. The whole atmosphere is resting on top of your head. So as you go down deep into the Earth, we measure it in terms of, well, how many atmospheres, like how much more pressure is going to be on top of you, is going to be pushing on you. So even at that, it's quite a ways down into the Earth, but it's not that far down at the boundary between the asthenosphere and the stiffer mantle. You're already looking at 0, let's see, if this would be 0.5, so maybe 0.2, right? So 0.2 million atmospheres. So that's a lot of atmospheres. Like 200,000 atmospheres are on top of you by the time you get down to that depth, okay? And then you use the temperature graph the exact same way. You just follow that line straight down. I'll use a different color here so you can see it a little bit better. You follow that line straight down until you reach the temperature line, which again is this bold line. It even tells you right here that that's the interior temperature. Follow that down until they cross. Follow it over. And then again, I'm going to zoom in so you can see that a little bit better. Halfway between these two, 3,000 and 2,000, what are my units here? Oh yeah, degrees Celsius. And right about there would be halfway, so that little line would be 2,500. So maybe what, 2,600 degrees Celsius, okay? So that, in a nutshell, is how you use this really complicated looking graph, and I hope that that was helpful.